Okay, today we'll be starting section 9.5. For those of you at home, we already worked through these for our warm-ups. So take a look, make sure that makes sense. But this is a review from first part of chapter 9. Okay, today we're going to go over what a binomial coefficient is and then show you how we can expand these binomials using the binomial theorem. Okay, we don't need the Pascal's triangle. We'll probably be skipping this last one. I'll show it to you at the end, but we won't spend a lot of time on it. Okay, binomial coefficient. Now, the formula is provided here, but I'm going to show you a way to do this in the calculator. We can figure out n things taken r at a time using this combination button. Okay, so I'll show you here in this first example. Okay, a binomial coefficient, if I look ahead, what do I mean by binomial? Binomial is something that has two terms and can be expanded. These are binomials. Okay, two terms. Okay. So to get the coefficient, it's just going to be the number that goes into these slots, which I'll show you on the next page. But for now, how do we get this number? Okay. All right, so notice the link here between n right here and r. Okay, so the binomial coefficient, you actually don't really need to write it this way, but I'm going to show you both ways to express this. All right, but let me show you where you can find this in your calculator now, okay? It's basically, if I were throwing some context for this problem, it's a way you can figure out, let's just say you've got 7 books on your shelf and you want to figure out how many different combinations I can grab 4 of those 7 books. This is a mathematical way to find that number. Combination, 7 books, taken 4 at a time. And here's how you punch it in, okay? If you have my calculators, you probably have to punch in the number first. So I got to punch in 7. Hit the math button along the left-hand side and go to PRB, probability. And I've got n things taken r at a time is how that reads. That's the third one down for my calculator. Okay, so what I did is I assigned 7 to n, and now I need to assign 4 to r. So if I punch in 4 now, I can get the answer to that. Okay, and if you have a newer calculator, they might let you type over those. So you might not have needed to punch in 7 first. So if you're having issues with your calculator, I'll come help you here in just a moment. All right, so that kind of answers that problem. If I had 7 books and I want to figure out how many combinations or groups of 4 I could take, that's it. Or I've got 7 basketball players. How many different lineups can I create with 4 players? 35 different lineups is what that means. Groups of 4, okay? All right, and you'll see how this ties in with the algebra soon, but for now, we just got to have that skill down. So that's just equal to 35. All right. So number 2, see if you can figure out how to punch that in. You don't necessarily have to write this part down. I'm just trying to make the connection. But go ahead and pause and write down or type in number 2. Okay, so a combination of 12 things taken none at a time. There's only one way to do that, so it's just 1. All right, 3, it's written this way. So make that connection. N goes first here in the combination. So this is a combination of 90 things taken r at a time, or 88, and that's how we're going to punch this one in now. And by the way, if you want a second enter, it might be any quicker way to do this, because you can just punch in over these numbers. So I could put in 90 right here, and then just put in 88 here, and get there a little quicker. So it gives me 4,005. 4,005. Try for 15. All right, we get 1 for that one. Okay, so let me show you how this binomial coefficient is going to tie into this binomial expansion. All right, next page. Binomial expansion, just kind of a quick shortcut way to expand these things. Like if I were to take a problem like 7, raise it to the 5th power, means I got to start by, squaring 2 of them, foiling it, and then I got to take the 3rd one and distribute that through, then the 4th, distribute that through. It would be a multi-step problem and take a very long time to do. The binomial expansion is a shortcut to that, and it follows a pretty easy pattern once you see it a couple of times. Okay, so let's start off with this real basic one. We're raising it to the 3rd power. This one we could probably get by with just expanding it and multiplying it the old-fashioned way. But as the exponents get bigger, it gets tougher, and we want the shortcut, okay? All right, so what I want you to realize first in this formula up here is the degree or power is always n. So n equals 3, okay? All right, notice here they got the n over 0, n over 1, and then it keeps going until you get n over n. Those are those binomial coefficients. Let's wait on that. I want to focus on these terms. So let's put this is equal to, why don't you put a little blank for the coefficient right now, and then let's get to the terms. It starts off by saying a to the n. So by a to the n, they're talking about this first term as a. All right, so I want to take x and raise it to the n power. The other term, b, is actually raised to the 0 power, and I usually like to put that in there too. So let's write this down as 2 to the 0 power. Okay. All right, just follow with me here, and I'll show you the pattern. Write another term, write a spot for the coefficient, and what's going to happen now is the powers of a just go down 1, and the b's start to go up. So this is going to go from the 3rd degree to the 2nd degree. And this is going to increase. Okay, stay with me here. Plus, write a spot for the coefficient. Keep that pattern going. So now this is going to decrease again. X is going to be raised to the 1st power, and 2 is going to be raised to the 2nd power. Okay, plus, spot for the coefficient. Now x is all the way down to the 0 power, and 2 is raised to the 3rd power. And that's when you know you're done. Okay, so look at the pattern here. It's degree 3, so notice the sums of all of these powers equal 3. 3 plus 0, 2 plus 1, 1 plus 2, 0 plus 3. There's one pattern you can check to make sure you're doing this right. Okay, the first term, x, starts at 3, works its way down to 0, and then just the opposite for the second term. 2 to the 0, 2 to the 1, 2 squared, 2 to the 3rd. Okay? Okay, now the binomial coefficients. Now we got to do the math and raise these to that power. We'll simplify here in a minute. The binomial coefficients are given this way. It's n over 0. Remember, n is the power, so it's 3. So this is 3 over 0, and then it just keeps going. 3 over 1, 3 over 2, and 3 over 3 is where it ends. Okay? And we know how to find those now. Some students actually like to write the combination in there. I don't care what you choose. You can write this form, or you can write combination of 3 things taken 0 at a time right there. I don't care. All right? Okay, so let's simplify this. Combination of 3 things taken 0 at a time. We just go to our calculator and plug it in, and it gives me 1. Okay? So I've got 1 here. Let's go ahead and start raising this to these powers too. X to the 3rd is x to the 3rd. 2 to the 0 is 1. Okay. Combination 3 things taken 1 at a time. When I plug that in the calculator, it gives me 3. So it's 3 times x squared, and 2 to the 1st is 2. If you still want to group these with parentheses, fine. I'm using dots, whatever. Okay, my calculator, when I punch in combination, 3 things taken 2 at a time, it gives me 3 times x, and 2 squared is 4. And then the last term, 3 things taken 3 at a time, that gives me 1. Obviously, in the 0 power is 1. 2 to the 3rd gives me 8. Okay, now I'm just going to simplify all these expressions and we get our answer. So this is 1x cubed. This is 2 times 3, so 6x squared. This gives me 12x, and that gives me 8. Okay, so that's why it's called binomial. These always start with, 2 terms inside of parentheses, and then we're going to raise it to some power. Okay, and we get it just like that. All right, so let me get you started on 6. I know this pattern's a little new. I want to get the first term going for you, and then let you try this one. Okay. All right, so it's up to you. Once again, I'd probably just keep that pattern going. I'm just going to leave a spot for the coefficient, or maybe you're ready now, right? N is 4 now. So maybe you're ready to just kind of put that in there, 4 over 0. Or combination, 4 things 0 at a time, if you prefer that. Okay? And then you start with the first term raised to that n power. So it's x to the 4th. Now, since there's a minus, I do have to use -3 here. That's why I want to get this started for you so you had it. This is going to be -3 to the 0 power. Okay, keep going. See if you can find the pattern, expand it, and then simplify it. Okay, here it is. Like I said, 4 over 0, 4 over 1, or you can start writing the combinations in there. You've got the choice of what you want to do. Here it is expanded. Here's kind of step 1. It's definitely a process where I should at least see at least a couple of these lines. Maybe you can go from here to the final answer, but I think it's good to do the step in between where I'm just raising these to these powers, getting these numbers. So final step, it's going to be x to the 4th, -3 times 4, so we should just subtract this, minus 12x cubed. Here I have 54x squared. 4 times 27. We get 108, but it should be negative. And then plus 81. So you can see how this really is kind of a shortcut. If I were to expand that out 4 times and do all the foiling and distributing, it takes a while. That gets me there a lot quicker. Okay, 7, I think you got most of the skills to try this one too, but now it's up to the 5th power. Let me get this one going here for you. And now the first term is not just x, it's 2x, and this is 3y, so I don't know, it's going to look a little different. Just to make sure I have enough room here, I'm going to start right down here to get this going. So my coefficient, it's 5 over 0, or combination, 5 things taken 0 at a time. Okay, and then I've got my first term, 2x, raised to the n power, and then the b term, which is -3y, is raised to the 0 power. And then this goes down, this goes up. So combination, 5 taken 1 at a time, 2x to the 4th, -3y to the 1st. Okay, go ahead and keep expanding. Okay, here it is. So here's the final answer, 32x to the 5th. This one just has a few more variables and numbers going on here, so we just got to be careful. Negative times these positives will be negative. All right, so when we have double variables, just put x to the 4th, y next to each other, throw your coefficients out front. That's how we'll organize it. Okay, so here we have 80 times 9, so 720. X to the 3rd, y squared. Next one's going to be negative again. This is alternating because of that -2 to the 3rd power. It's -8. So that gives me -80 times 4, -320. X squared, y to the 3rd. Okay, next one, 5 times 2 is 10, plus times the 16, so plus 160. And the last one is going to be just -32y to the 5th power. Okay, so there's the final answer. A lot of terms. Should be 6 total terms. It's always more than one of the degree. Okay, I'm going to show you one more. Let's take a look at number 8. This one just asks for the nth term, one term. So if I say n equals 4, just go in order. This is called the first term, the second, the third, the fourth. So sometimes it might just be asking for one term, so you don't have to simplify them all. It makes it a little bit shorter. You just got to start expanding it to get this going. All right, so to find the nth term in the expansion of this binomial, how would we usually start this? We'd say combination. Oh, let me pause and restart this.